Okay, this is 10.1, using properties of tangents. You should have already copied out these definitions, so let's take a second and talk through them. Like we've been talking about all semester, language in geometry is super important. So the precise definition of a circle is that it is a set of points. So it is a set of points, a group of points, that are all equidistant from that center point. So we don't call it a curved line or something like that. We call it a set of points. Okay, and so then our notation for a circle is right here. We define a circle based off its center. So this small circle with a dot in it and the capital letter P would be read circle P, circle P. Okay, so a radius you are obviously already familiar with. And then a chord would be a segment with the two endpoints on the circle. So those two endpoints are part of the set of points that are equidistant from the center. And then diameter is a special case of a chord that also contains the center. A secant is similar to a chord, but it's the entire line, not just the line segment. So be careful, a secant is an entire line, where a chord would be just the segment. And then tangent, we've been using tangent as a trig function, so don't get that confused. There are two tangents in geometry, one in trig and one with circles. The circle tangent is a line that intersects the tangent at exactly 1 point. So cannot be 2 points, only 1. Okay, so let's move down to the bottom of your page and let's apply these definitions. So number 1 says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So segment BC, that's the radius. It's got an endpoint on the circle, endpoint in the center. Radius. Okay. Ray DE is intersecting the circle at 1 point. So we'll call that a tangent. Tangent. A tangent can be a full line or a segment or a ray. We would all call them tangents. And then one other definition, this point B, where the tangent intersects the circle, we would call that the point of tangency. The point of tangency. Okay. Segment AB, endpoints on the circle, goes through the center, it's a diameter. Segment AF, endpoints on the circle, doesn't contain the center, it's a chord. E, line AF intersects the circle in 2 points. It's going to be a secant. So the segment was the chord, the whole line is the secant. Okay. So over here in number 2, we've got a coordinate. So these are pretty easy, but we've done a lot of stuff with coordinates so far. So the only difficult part of this is being sure you know which circle it's talking about. So the radius of circle A is the circle with a center at A. So the circle with a center at A is the small circle. The big circle has its center at B. So the radius of circle A would be 2 units. And then the diameter of circle A, 1, 2, 3, 4 units. The radius of circle B, so now we're talking about the big circle with the center at point B, would be 1, 2, 3, 4 units. And the diameter of circle B was going to be 8 units. Okay, so let's talk a little bit now about coplanar circles. So coplanar circles, as you could guess from its name, is two circles that are on the same plane. Coplanar circles are two circles that are on the same plane. So that would mean all of the points in both circles are all contained on the same one plane. So one way you could have coplanar circles is they could intersect in 2 points. They can intersect in 2 points. They kind of look like a Venn diagram. Another way you could have coplanar circles is they would only intersect in 1 point. Only intersect in 1 point. So remember, up here a tangent intersects the circle in exactly 1 point. So in the same way, this intersects in exactly 1 point. So we can call that a tangent circle. And then there are coplanar circles with no points of intersection. They share no points in common. So they can either be completely separate like this, or they can be one within the other, and we would call those concentric circles. Concentric circles are one within the other, but they don't intersect. Okay, so a common tangent would be a tangent line that is common to two circles. So it's going to intersect both circles in exactly 1 point on this circle and exactly 1 point on that circle. So one example of a common tangent would be like this. It intersects that circle at 1 point and that circle at 1 point. Another way we could draw a common tangent is kind of on the diagonal. Common tangent. So common tangents intersect both circles exactly 1 point. Okay, going over to the back, let's practice that. So here on number 3A, we've got two coplanar circles. You can notice they intersect at 1 point, so we would call those tangent circles. So let's draw the common tangents. Well, I could have one coming down on this side. I could have one coming down on this side. And then I could have one going straight through the center through that point of tangency there. So overall, that's going to make 3 common tangents. So here, these are two coplanar circles that intersect in 2 points. So similar to this one, I'm going to have the 2 on the outsides, one there, and one there. But unlike A, I can't draw a common tangent through the center because that would intersect the circle in 2 points, and that would make it not a tangent. Okay, so I want you to go ahead and pause the video and do C, D, and E on your own. So pause the video now and do those 3 on your own. Okay, so now you should have finished doing these 3 on your own, so let's go over them. C, I found one common tangent. These are tangent circles. They intersect at one point, and so there is one common tangent through there. Any other line would either intersect at no points or at 2 points. D, I have no common tangents. No common tangents. Any tangent line to that interior circle would intersect the outside circle at 2 points. So you couldn't have any common tangents that intersect both at only 1 point. So there are no common tangents for that one. And then E, I got 4 common tangents. There's the top, the bottom, and the 2 diagonals. Did you get all of them?